Hello and welcome to our next exciting last final unit for the 2015-2016 school year. Today we're going to be talking about theoretical and experimental probability. Now last class we introduced you to what probability is. It is the likelihood of something occurring. And so today we're going to talk about the difference between what is theoretical probability and experimental probability. If you look at the bases of the words, theoretical sounds like the word theory. So it is what it's our idea of what should happen. Where experimental, you see experiment in the word, that is us actually doing something and collecting data based on an experiment or something that we've actually done. So our learning targets are to determine a theoretical probability of an event based on what we know about the object that we're doing, and determine the experimental probability of an event based on data that's given to us. We are actually going to be doing experiments in class, so we'll tie right into that. Describe changes in the experimental probability as the number of trials increase. That means when we say the number of trials, that's how many times we're doing something. So what happens the more we draw marbles out of a bag, or the more we draw different things out of flip a coin or roll a dice, what happens to the experimental probability. And then investigate and describe the difference between the probability of an event found through experiment or simulation versus theoretical probability of that same event. So those are our learning targets, what we're working toward. What is the difference between theoretical and experimental? I just went over that at the beginning. Theoretical is what we think is going to happen based on what we know about the object. For example, looking at this number cube, we know from our last class that a number cube has 6 sides. So we know the different things on that number cube are the numbers 1, 2, 3, 4, 5, 6. So if I said, what is the probability of rolling a 5? We know theoretically it should be 1/6. But if we do an experiment where we actually roll the dice, I got a 6. I got a 5, so I got one of them. I got a 6. I got a 3. So if I look at, I'm going to roll it 6 times. I got a 2. I got a 6. Okay, I've rolled it 6 times. So out of 6 times, I did get 1 5 out of that. But look how many times I got a 6. I got 3 6s, and that's how probability works. So sometimes the experimental probability doesn't match up with theoretical. The 5 did, but what if I said how many times, because theoretically, how many times should I get a 6? Should also be 1/6, because there's only one side that has a 6 on it. But in my experiment, it happened 3/6 or half of the time. And that does not match the theoretical probability. So experimental is what actually has happened based on my experiments or my sample, and theoretical is what should happen based on what I know about that object. So take out your notes. We are going to be on page 3, I believe, or 4, I can't remember. It says theoretical and experimental probability notes at the top. So the theoretical probability, let me highlight that. This is theoretical, and that is the expected probability, or what we think is going to happen. And that is found with a formula. And that formula is the same as what we did. It's right here. Theoretical probability is the number of possible favorable outcomes, or what we want to happen, based on the total number of outcomes. So like with a dice, if I'm looking at, or say I'm looking at a card, how many 4s could I pull? The number 4 in a deck of cards. There are 4 of them out of 52 total cards. So this is your total number of cards, and this is how many fours there are. There are 4 of them. The one mistake that I'm going to tell you that I see students do all the time is with dice and with cards, they're going to say, you know, if we say, what is the chances of rolling a 6? They're going to put 6 as the possible outcomes over 6. That's not correct. That's saying it's going to happen all the time. Not true. So that's the mistake you're going to make. It's not the number that we're asking you to find or that we're asking to happen. It is how many of those numbers are on the object or in the deck of cards or things like that. So the other thing we're talking about is experimental. And that is an event, the probability of an event determined by carrying out a simulation or experiment. So we are actually doing something. So this is what I think will happen. And this is what actually happens. And there's actual data that you're going to be given that you use. So that formula, if you look here in the middle, is the number of times the thing we wanted to happen happened over the total number of times we tried. So this is how many times we tried. So if I rolled a dice 10 times, the bottom number would be 10. If you are shooting free throws in sports, then your probability is based on how many times you've tried to make a free throw, how many shots you took. All right, so let's talk about this. If you flip a coin, what is the theoretical probability that you will flip heads? So remember, with theoretical probability is what we think and know about a coin. Well, think about a coin. How many sides does it have? That's our bottom number. It has 2 sides. It has heads and it has tails. So what is the probability that when you flip a coin you're going to get heads? Well, there's 1 of them out of 2. So 1/2 or 50%. But if a coin, here's our experimental, if a coin is flipped 10 times, how often should you get heads? So it's flipped 10 times. And if I know that it's 50%, you have to ask yourself, well, out of 10 times, if it's 50%, how many times should I get heads? It should be 5, because that simplifies to 50% as well. And if it's saying how many times should I get it, it is still theoretical. Even though I flipped 10 times, that's still theoretical because it's not saying out of those 10 times, this is what I got. So that's the difference. So let's keep looking. If you perform, here we go, if you perform an experiment, this is key. If you perform an experiment by flipping a coin 20 times, 20 times is our total. Will you always get heads 10 times? Why or why not? What do you think? If I always do it 20 times, am I always going to get 10? The answer is no. And it is because the coin can land on either heads or tails. Regardless of the theoretical or what should happen. That's probability. So if you think about this, when you do a science experiment, you have a theory of what you think is going to happen. But when you do that experiment, it doesn't always match what you think is going to happen. That's where experimental probability comes in. The experimental, and we're going to talk about this in a minute, when you're doing it, it doesn't always match what, numerically we think should happen. So we're going to talk about why that is. So if we perform the experiment, then that is experimental probability because we did the experiment. Now, this says, suppose you performed 2 experiments. In the first one, you flipped a coin 20 times and counted the number of times heads came up. And in the second experiment, you flipped a coin 2,000 times and counted the number of times the heads came up. In which experiment are you more likely to get heads 50% of the time? And the answer is, when you do it 2,000 times, because there are more chances. For it to land on heads. Just like if you think about, we talked about when you use probability, and the lottery was one of them, or a raffle. The more lottery tickets you buy or the more raffle tickets you buy, the better your chances of being drawn. This is the same way. For flipping a coin, the more chances, the more, more you're going to come close to what you want. So the last thing that we're going to talk about, and this is what you have to know, is this law right here, the law of large numbers. In experimental probability, as the number of trials increases, the experimental probability gets closer to the theoretical probability, and you have to know this. So basically what that's saying in a nutshell is the higher the number of times I'm doing something, the closer I'm going to get to what should happen in theory. So if we go back to that question about which one, 20 times or 2,000 times, 20 times is a very small amount, so the chances of it getting 50% are very small. But if I do it 2,000 times, the more times I'm flipping the coin, the closer I'm going to get to the theoretical, which is 50% of the time. So that's what that law is saying. Not too confusing. So think about it. Which experiment would be closer to the theoretical probability if Mary rolls 2 dice 6 times to see how often she gets a sum of 4, or if Mary rolls 2 dice 60 times to see how often she gets a sum of 4? Which one would match the theoretical probability? The second one, because it's 60 times, which is a lot more than just 6. So the more times I do something, the more likely I am to have what is expected. And we're going to continue the notes in class because it's all about doing some trials and some experimental probability. And so we will stop there. Don't forget to take your Edmodo quiz to talk about simple probability from last class and this video.